Said?
Good evening, everyone. It's my absolute pleasure to welcome you all. Today, we are looking at the future of urban mobility, and we are incredibly proud that this future is being built right here at IIT Madras. Our guest speaker is a core team member of the ePlane company, the startup that is building India's first electric plane taxi. Their flagship aircraft, the E200, is designed to make commuting that faster, turning a 60-minute traffic jam into a 14-minute. They have already made history as the first private plane company to receive design organization approval from the DCCA. We are thrilled to be joined by the man shaping the form and function of this technology, the Deputy Chief of Design, Mr. Sri Raghav. Raghav leads the conceptual and preliminary design team at ePlane, which means he's quite literally designing the way the flight will go. Please join me in giving a warm welcome to Mr. Sri Raghav.
Hey, thank you, sir. Hi, guys. So, I just present myself. Are you able to see the screen?
Yes, sir, it's
Yes.
visible.
Yes. Thank you for the intro, Syed. And so,
Said, there's light noise in background.
so I'm still in the office, so I cannot help much about that.
Okay, okay,
All
okay.
the yeah.
Fine, fine.
Sorry about that. Yes, yes. I just thought about this presentation and I was thinking like, how can I make it more welcoming to this particular audience? So I didn't capture much of the technicality here, but I just am giving a very what do you say, a bird's eye view of how it is to work in a startup and how it is to design this kind of app. I just captured that part alone. And can I go ahead?
Yes, sir.
Hello?
Yes,
Yes.
sir.
Yes. So around four statements were given to me, and I was asked to address those four statements. But I'm just trying to capture only the first two of them, like how to design a compact aircraft and why a compact aircraft in the first place. Second thing is the building from scratch, the early stage team dynamics that we play. So there is a specific reason why I'm choosing these two alone because, uh, as the founder of the company always says, one thing is to develop an aircraft itself. Second thing is to develop the company itself, the aircraft company itself. So the latter part is much more difficult than the first thing because uh, that includes a lot of interpersonal skills that we have to develop as an engineer or scientist. Because technicality or physical principles is something that we try to learn in college or in school, but this interpersonal skills that is very very mandatory for us to hold a team together or put the team together and then holding on to that. It's very crucial for any company. So the latter part is much more difficult than the first one. Just having said this and having given a context about what I'm going to talk to, I'll just move on. Yes. Um, yeah. So when we design a compact aircraft, like there are two major things that always an aerospace engineer should be concerned about and will be concerned about. That is weight and drag. So when we look at eVTOLs, it always tells us three categories of eVTOLs. One is the typical multi-rotors that we see, which is basically glorified drones, which we usually see in common public functions and all, where people actually put a it's more of a brutal way of engine where we put a multiple rotors and then we simply add a battery and then we go for a mission. So this is one way of designing an aircraft. The other way is that you know what you are going to design for, which means you are very clear about the market that you are going to address, and then find a problem statement and then design a solution around that particular problem statement. Now, when you think about the aircraft that you see on the left side, the top one, which is basically known as of widow maker. It's known as widow maker because for a reason, because the crashes that this aircraft has seen is multiple. The main reason is that they have a very very complex tilting mechanism, which means the vertical takeoff and the forward motion is achieved through the same set of engines, which means it's not optimized for vertical takeoff, neither is it optimized for the forward motion. Now, this kind of engines will all obviously have to more weight and then more drag. So we want to avoid this kind of design. So that is the first thing that we are meeting to, that what are we designing? Are we going to design something that is very complex but looks operationally simple, or are we going to design something which is very simple and easy to operate? So the phrase easy to operate is the mantra here, which means you design something which is as simple as that to operate instead of having so much complex mechanism. Which so whenever in engineering, whenever you show that it is simple with the help of a complex mechanism, the regulations always ask one question: what if that particular thing fails? So you do any number of solutions, the number of solutions you add always put an 1 plus 1 to that, which means if it fails, I am going to do this. That is the key concept here. So in that way, we decided that we will go for a very simple configuration wherein there will be two set of rotors, one for vertical takeoff and one for the forward motion, which means we are not going for any kind of complex mechanisms. That was the concept that we decided, which means our approach to compactness of the aircraft will have to go through thing like having a very simple configuration. Team, guys, if at all I am more fast or if at all you need any clarifications, you can ask me. I will pause down or slow down. Yeah.
I
So
think you can slow down a little bit. Like it's too fast, what I feel at least.
sure. Thanks for the feedback.
Yeah.
Uh, yeah. Correct. I got you. So as I mentioned, to design an aircraft, you must to design any product for the market in that sense, you must always understand the problem statement very clearly that you are going to address, and then choose a solution or a proposed solution which is around that particular problem. Which means you always try to hit the bullseye. Which means you want to address urban air mobility. Which means people will see aircraft that are flying on a daily basis, like taxis, which means it has to be as simple as possible. If at all one thing fails with that, how are we landing? So there is one common or very famous saying: takeoff is optional, but landing is mandatory. It's that way. So you take off and then you are cruising in there, but you see that something fails. How are you going to address? So the first step or the zero step to address or stop something from failing is that don't do such things. So in my point, the main point I'm trying to put is that avoid looking for complex mechanisms which makes operations simple, which may look like the operations are very simple, but the design itself and the regulations itself will have a lot of hurdles to prove that it's not failing. So in that way, we decided something we have to design is very simple. Second thing is that compactness. So why should an aircraft be so compact? So the phrase urban air mobility means that you have to take off and land within cities, which means if you're having huge wingspans or huge dimensions of the aircraft, it clearly means that you are resetting something wherein you will not be able to access constrained spaces in the city. So the idea of compactness or the requirement of compactness comes from this only, which means you will go to cities wherein the space may be compact and the landing space may be very tight. So you have to address that issue. Now that is having a compact airplane is one thing. Second thing, you should have the aircraft to fly so slow also. So can you see what do you say counterintuitive things? An aircraft should be compact at the same time it should fly slower. So what does that mean? Typically, an aircraft with a larger span, this particular aircraft can fly slower because it has a very large wing, and an aircraft is compact compactor will have to fly faster. Now, what the market demands is that you need to have a aircraft which is having a smaller footprint, but should have the characteristics of having an aircraft that flies slower. So, can you imagine that kind of a problem? It's very difficult. That is the real trick here, which means you need to design an aircraft which is much smaller in terms of footprint, but at the same time, it must be able to fly slower also. So, in a very basic sense of physics, what it means is that the amount of lift that is generated by an airframe is always dependent on the area of the wingspan, sorry, area of the wing. So you have a lesser area, but at the same time, you have to fly slower also, which doesn't go together. Now, this is where the way we thought about such an aircraft came into picture. Am I clear up to this point, friends?
Yes, sir.
Yes,
Cool.
sir.
Yeah. Yeah. So now I'll address the somebody. Did somebody raise the hand?
I think it's a mistake, I guess.
Cool. So you see. So the chart that I'm showing here shows the pioneers of the eVTOL industry. So the second quadrant shows aircraft like third quadrant shows aircraft like Joby and Lilium, and then we have vertical Eve Aerospace Archer this, and then we have volocopter hands. Now the x-axis goes with speed, and the y-axis stands for the range. So if you look at the quadrant wherein volocopter and EHAN are there, they are simple multi-rotors, which means they have low speed and short range. Now we have another quadrant opposite, just opposite this, wherein you have a long range and a higher speed. And we have the next quadrant wherein you have a high speed and a short range. Now, none of these things will fit into an exact urban air mobility because for multiple reasons. For example, you consider the multi-rotors like volocopter and EHAN. You can go and browse these things, how they are looking about. So volocopter and EHAN are basically glorified drones, which means they don't have any wings, which means they are highly inefficient. So the ultimate aim of designing a very efficient aircraft in terms of urban air mobility is that you should be able to do multiple hops within a city. Say you take off, you travel for 10 kilometers, you land, you just charge for something or you don't charge, but take off, go another mission complete. So if you are able to achieve multiple missions with one battery charge, that means you have designed a very thought nice aircraft for the urban air mobility, an economical aircraft. Now, having said this, these have very short range and low speed, which means they will not fit into a typical urban air mobility aircraft. On the other side, we have Joby and Lilium, which Joby is one of the, what is it, aircraft that company that started long back, around 16 years back, still going through certification because of the complex mechanism that they have in terms of tilting the rotors. Now, these aircraft, they actually started as urban air mobility, which means they wanted to address the problem wherein people want to move from one point to another point within a city. So what they did, they had the typical conventional aerospace approach wherein you put a very long wing, you make the aircraft heavy, and then you fly faster. Now, from the problems that I mentioned earlier, an aircraft that has a larger wingspan is not suitable for an intra-city operations because it will not be able to take off and land from constrained airspaces or vertiports. Now, at the same time, now we are going to the other part wherein fast moving aircraft. So, for example, a JOV will have to travel at approximately 300 km per hour. So, imagine us traveling from, say, Guindy, IIT Madras campus to the satellite campus where the ePlane factory is. It's approximately 30 kilometers. So, you take off from there. By the time you accelerate and then you reach your cruise speed, you are already half past your mission, which means you are constantly operating your aircraft at inefficient regions. So you will have a lot of power consumption. In that way also, you will not be able to reach your design speed, or probably you may overshoot your design speed before you, before you, after you reach the destination point. You start from point A to point B, they are 10 kilometers apart, you take off. By the time you reach cruise speed, you're already crossing point B. Uh, in that sense also, you are not going to design a proper intracity aircraft. So what these guys did is that both Joby, Lilium and Vertical Eve, Archer, everyone, they repositioned themselves from something called urban air mobility to regional air mobility, which means traveling from one city to another city at a higher speed. So they started something, they were unable to achieve that, so they created a new market. Now, what we try to do is that we are trying to address the area where you have a long range and a low speed energy, which means you take off from one point in city, you travel 10 kilometers at a design cruise speed, which is approximately, I would say, 150, 160 kilometers per hour, and then you land, you unload things, unload the patient or the passengers get away, you load in new things, and then you take off, and then you land. So you will be able to address at least two missions for a given chance. Now that is the market that they are going to address. Now, how do we address that? As I mentioned, it's a compact aircraft, lesser footprint, but at the same time, a slow moving aircraft. So that is the problem that they're going to tackle here. So can you clearly see there is no other aircraft company in this world who can address we had a different thought. We thought, what if the vertical rotors keep operating when you move moving forward? It's actually a philosophy of life cost that we came up from. Because you buy something costing so much money and then you don't utilize it, which means the money is wasted, the product is wasted. It shouldn't be that way. You design something, you try to utilize that through the entire operation. That's how you try to minimize your power consumption. So what we are doing, we are not having any dead weights and we are not having any drag producing components. So this way we had a patent itself filed across 40 countries, out of which we have already got 10 from 20 countries. That when you are operating the vertical rotors in forward motion, we will be able to conserve a lot of power and energy, which can be utilized for multiple trips. That is the whole idea. Guys, any questions or anything here? Are you following me?
Yes, sir.
Cool. If at
Fine.
all I'm again moving fast, you can tell me. I will try to slow down further.
No, it's fine, sir. Thank you.
Cool. So that's the whole idea, my friend. Like you have something for a certain part of the mission, and then you are switching it off for the highest part of the mission. That doesn't make sense. You are simply carrying dead weights and draggy components through the whole flight. So you try to optimize the whole flight, thinking that this particular rotor used for vertical takeoff will be operational for the whole mission. That's the whole idea. In other words, I would like to simply put that do not look at the vertical takeoff part and the cruise part separately. Always try to combine each of them from the initial phase of design and then look so that your aircraft can be designed with ultimate efficiency through the mission. So that is how we were able to reduce the weight and reduce the takeoff cost. Now, we have spoken enough about the dimension of the aircraft. Now, what happens when it comes to weight? So, being compact aircraft is one thing. Now, a compact aircraft with a which which weighs like a mountain cannot land on a typical three-bedroom apartment. It's not gonna happen. So we actually went into literature, we went into multiple surveys, and then we derived our own parameters wherein we were clearly seeing that there is something called structural mass ratio that you see here, SMR of 23%. If you look at the conventional aircraft, the SMRs are all high. But for us to enter into market and for us to push harder, we saw that we must always have a structural mass ratio of 23%, which means your structure, all the structural mass put together, you should not be weighing more than 23% of for structures. This constraint was hard impressed on company for us to uh, put a viable product. So one thing is that you find out the requirement, and next thing is that you find out that this should be my target. So once you have the target, you have the money. So that's the ultimate aim. In a startup, you should know your requirements very, very well. You always put the requirements on the top of the bar and you say that if you are breaching this, then you're not in the game. So, and then all other things should follow, which means you always try to look at the designs which will always help us to reach that margins in terms of screw speed, in terms of structural margins. So this is the whole idea of designing a compact aircraft with a very, very lesser weight compared to other class of aircraft. So this is where everyone wants to do every part of the aircraft, which will not work practically. And at the same time, you will not have enough experienced people. Third thing is that the worst part is that none of the startups will have an immediate hierarchy, which means, as I mentioned, when multiple people come in, they may or not have experience. And if you bring hierarchy at that level, hierarchy means you will have always have a reporting strategy, which means you obviously brings the mentality that I am junior to you, I am senior to you. That will not work for a startup. Second, and as a result of which, we'll have an attrition rate, which means people start moving away from the jobs that they went for. They come with certain imagination, and then they see it's not going to happen here, so they move on. And next point is that everything looks good in the computer, everything looks peaceful in the computer, but the moment you start putting things together, it's really harsh, man. You will see surprises. You will see a lot of surprises, which you will not even imagine. The last point is that whenever it comes to disruptive technology, you will not have any surprise. You will find only very minimal overlap between the available literature and whatever you are going to develop. So at this point also, it's all about our imagination. You imagine that you are going to design this kind of an aircraft, or you are going to design this kind of a problem. To address this kind of a problem, you have to be a lot of bring in a lot of innovation. So all these points that I mentioned here is literally like putting different frogs together and then like trying to count them. You don't know what you're doing. You keep on doing the same thing. You get a frog, you put in there, you count one, it jumps out, and then you don't know with the same frog or a different frog. You try to do that. So it's a very dynamic moving goalpost that you will see in a startup. But the problem that you're addressing in a startup should always stay the same so that you don't deviate. The reason I'm telling is that you start an aircraft company and then you find that drones make business. Which is like drones are simpler to make. There are no certification rules. Even though there are certifications that exist, it's easier. So you are moving from drone company, sorry, aircraft company to drone company. It may look like you have solved the problem, but it's only for a short term. You find a problem, you stick to the same problem, and then you move on. That's the ultimate mindset here. How? Second part is the deadline. The deadline is always steady, which means that you will feel that the deadlines are unrealistic. Startups are unrealistic always. It's which means people will always try to feel that this is not doable, and then they will take a lot of work from homes or different leaves, all those things. So these things should be avoided at initial state of a startup, and people tend to do that because there is no reporting hierarchy. There is they feel that only they are the bosses, so they don't ask anyone. They just go on an undefined leaves and all, which is not good for a startup. And you being honest to yourself is the only thing that you can save in a startup. Only through that way you will be able to turn into a leader, and only through that way you will be able to attract more talents. That's how we grew actually. Now, the third thing, we spoke about the problem statement, we spoke about the
Like, how are you planning to solve that?
Sorry, can you please repeat?
Sir, the energy bottleneck, like in aircraft market, the main thing in electric planes is the how you are going to power that.
Correct.
So how are you trying to solve that?
You mean the charging itself?
No, sir, in const like long distance plane, how what are you planning to power it up?
Right. So, as I mentioned, we are not trying to address a problem that is like for a, what is it, a long range aircraft. While the range that we are focusing on, we are more like auto rickshaws, I would say, which means you try to address. See, we are not going to utilize auto rickshaw for 200, 300 kilometer rate. You only
Yeah,
take it in intracity. Like, for example, you travel from here to central railway station or from here to the airport, which is typically the max of 15 kilometer. That's interesting thing. I would like to add. Thanks for the question, by the way. If you look at
why
any
not?
city, any major city in India, the radius of the city from the city headquarters to probably the outskirts is maximum of 20 kilometers, which means, for example, a patient is getting affected at the entrance of a city, we will be able to lift him off, airlift him, and then we'll be able to put him to the any part of the city, which is the closest multi-specialty hospital, for example. So we are always looking at the short ranges, which means we will take off, we will go for 10 kilometers, 15 kilometers, we will land there, probably charge, or based on the capability of the aircraft, we take off and then move on. So we always look at short ranges. That's what we do.
So it will be a long for a long distance. We will use a chain like that.
Sorry?
To travel a long for a long, we had to use a like chain a chain thing like one by one.
Need not be. So the roadmap for E200, the roadmap for ePlane is that initially you start with this, but slowly we try to improve the passenger capability. And so, see, the whole idea is that the reason we are trying to stick to only two passengers is that because if you look at the most of the Ola Uber rides, you will see that most of them will have only one passenger. This is a very famous research that was done by one of the consultants that we have. We were able to see that 70 or 80% of the taxi rides are commonly single passenger. Now, the more number of passengers you have, which means passengers for a longer distance, it is not going to be economic for our the company.
Yeah.
So the initial stages are only to go for short ranges. And as you mentioned, in the future, we ourselves are in the roadmap of designing bigger aircrafts and larger aircraft for us to travel from one city to another, or even traveling from here to say Hyderabad or here to Pune. Things like that.
Yeah.
That's also
And
the
sir, we are focusing on a battery operated aircraft or fuel operated like.
excuse me. All these things are battery operated. We, as I mentioned, we will look at different kind of aircrafts. We will look at different kind of powertrains or hybrid powertrains for bigger aircraft and aircraft that can move faster or long distance also. So
Yeah.
that's in the pipeline. But now it's only electrical.
Okay.
Yeah.
Sir, what do you think it is going to cost to the customer when it will be finally in the market? Like,
Right. So by customer, are you asking about the customer that who can actually procure the aircraft himself, or
yeah,
is it like? So our aim is not to sell the aircraft as such. We will not. We will have to. We will, of course, we will have some partners who will actually operate the aircraft. For example, you see Airbus and Boeing. They don't. They are not. They are only the OEM. They don't operate the aircraft. So they actually design the aircraft and then they give it to people like SpiceJet or people like Air Arabia, Emirates to operate the aircraft. So we will also have the same thing. We will not who actually work hand in hand with people like the Ministry of Civil Aviation to develop things like the charging infra, the overall maintenance and overall organizations. How do we develop the piloting skills, simulator setups for this for us? All those things are happening. So it's not like we are thinking only about the aircraft. They're developing the whole ecosystem. Having said this, we are having a plan of talking to the cell phone operators, the mobile operators, to give their towers for us to put local, what do you say, weather sensing radars for us for a what do you say, real time feedback for the aircraft to do the dynamic path planning and all. In addition, one more point I would like to add is that when you have the destination, the origin and destination fixed and the path fixed, the way we can handle the traffic is much more easier. If you look at people, if you look at the way the developed nations regulate the traffic, it's very clear. They have specific lanes wherein specific speeds are allowed, specific locations are allowed. In a similar way, they are able to stack the altitude at different levels. Say, for example, this level can is only meant for aircraft traveling with specific speed, and you can put in another layer wherein you can have aircraft can go at higher speeds. All these things will based on only on the point A and point B, source and the destination. So if you are able to pre-plan these things, the traffics are easily manageable, and these are not a simple statement. It's already happening worldwide. The air traffic algorithms are actually coming in. It's known as advanced air mobility actually, which includes the uh, air traffic control also. Yes.
Yes, I have a one question.
Yeah, please.
Like, how will you manage the landing pads for the aircraft? Like in big metro cities like Chennai and Delhi, how will you manage the space for the landing? And after one ride complete, will the plane go to its origin or stay there for the next ride?
No, no, no. So, I mean, this is also typically like every what is the operator behaves. We may not actually. This is like you are booking an auto wala, and he tells that I have traveled from here to your source empty and asking for more money. Very similar situation. So what we have, the way we have to plan the path is that, for example, you would have seen an aircraft never flies empty from one point A to point B. This is a conventional aircraft because it's not fuel, it's not economical for us. Similar way, we will plan the path wherein you take off with the bare minimum payload, at least in two seats, one seat has to be filled. You go take off and then you land at the destination, and then from there you need not come to the source itself. You can go. That is the source now. From that source, you can go to some other destination. The aircraft can keep moving around. It's very similar to your Ola Uber rides. It doesn't have a specific source and destination. It always varies. It's that way. So at all these places, you have to develop charging infra. That is where the cost actually comes in, which means if an aircraft is capable of having multiple hops, which means your aircraft, at the worst case, you can actually fly empty from one point to a nearby station and charge also. That's one way of looking at it.
And like, how will you deal with the space? Like, the space is the major concern of this project.
Yeah, correct. Correct. So is so that is the main problem with the bigger aircrafts. So uh, the bigger aircrafts will always ask for more and more infrastructure, whereas our founder has coined the word named as defrastructure, which means you shouldn't be asking for more infrastructure. In fact, you should be able to modify a bare minimum of the existing infrastructure and you should be able to land the aircraft there. For example, we have already made a proposal asking that can we actually modify the rooftops of existing bus stands or existing railway stations, existing metro stations for us to land the aircraft and take off from there. So it's one way of looking at the problem. We are not asking for any more additional infra or additional space. You are just trying to modify a bit of the existing infra itself for us to land and take off. It's one way of looking at the problem. It is possible that bigger aircrafts will ask for more sophisticated infra for them to land and take off, which is not going to be economical for them. Yeah. Yeah, guys. Any more questions?
Yeah. So what is the range of our air taxi or air vehicle?
Yeah. So at one charge, so flying fully, taking off and then moving on, you will be able to travel 100 kilometers. But as I mentioned, we are not looking for that. We are going to break the takeoff and landing into multiple hops, wherein you see that you will typically travel area, and then you go to a 20-kilometer radius, you drop your passenger there. Yeah.
Sir, like if I may ask, what is the core motivation behind building all this? Like it is solving the traffic problem or
It is
what
not
is
about solving traffic problem. That's a very, very what do you say, poor way of telling the customer that the traffic problems will be all solved. That's not the case. The main reason that we are seeing that we can develop an electric aircraft specifically is that for two reasons. See, the IC engines, the helicopters, for example, will have to pay a lot of money in maintenance activities. The maintenance activities comes only because there are a lot of moving parts. Now, when you remove all the moving parts, for example, gears and oils, lubricants, you are replacing all these things with simple electrical wires and motors, which means you are reducing a lot fuel card. You just look into the kilometer cost per passenger for a given unit distance. It's much lesser for an electric scooter or an electric car compared to a conventional this one. Electricity is always cheaper. That's the whole point. It's not about solving a traffic problem. That may be a byproduct, but the main problem is the solving the economical problem, which means people will be able to afford travels, transport at a much lesser cost at much less reduced time. That's the whole idea. And this can be handy for things like air ambulance, where people they are actually playing with people's life. So I'll give you an example, guys. So we were actually talking to the Army Design Bureau in Delhi. They gave us a very, very interesting statement. So a Jawan or an Air Force guy who is at the border and who is also injured has very, very less probability of surviving. At that case, if you are able to put an aircraft and then lift off from there and then drop him, he at least has a 20-30% chance of uh, coming back to life. That's a very, very key point. You why don't you attempt? So whenever a problem comes, it's always about what do I lose by not doing it? If I do it, what will happen? That's the mindset you can have. You address statement only with that kind of mindset. Don't think much about what will happen if I do. Think like what will happen if I don't do that. What are you going to lose if you do that? Nothing. So address the problem. So that's the whole idea here. You bring this thing to India. See, for example, look like the drone rules that came up in 2021. We were the India was the first nation in the whole world to bring up a very, very clear-cut drone rules. In a similar way, the conventional aircraft era is done now, done and dusted now. Our government or our engineers doesn't have much to do there. But EVTOLs are something that is coming up right now. So India has a lot of potential to address this problem and be the first in the whole world to bring this into real life application. That's the whole idea.
like one last question? In
Yeah, please.
India, the corruption and all these regulations are main bottle point for such a technology. So how will you deal with that?
Now, that's what is there. It might have been the case before, but so I'll give you something very interesting. The way uh, regulations are helping us right now is that two officers from the central agency have been deputed in Chennai only to work with us. And those people are coming and working with us on a weekly basis, trying to understand how an aircraft is designed like this, how regulations are being applied here, and how the airworthiness criteria can be met. This kind of a mindset is coming up in the central now with the help of the current government, which means we are already in the game, and it's not us pushing them. It's the reverse way now. The regulations and the ministry is pushing us because if we lag, no, there are foreign players who are waiting to enter India and then establish the market. Once that happens, we are again stuck in the same loop wherein there are foreign products, they come here, they sell here, we only use it. We will not become self-sufficient. So at this point, the government is pushing us for us to get a product there. That's how things are happening right now.
It's good to hear that, sir.
Actually, it's happening right now in India. When it's not the old way of thing that's happening. It's actually a lot more positive way of operating the industry is happening right now. Yeah, friends. So I think we have reached 7:45 now. Any questions left? I'll have to jump into my next meeting.
Yeah. Uh, First of all, Shri, thank you very much for coming uh, and joining the
Well done.
session. Very insightful
Cool.
session was. I
Thank
have
you.
one question.
Please
So
go.
we know Professor Satya Chakravarti is a co-founder of the ePlane company, and he's also there in the tutor Hyperloop. So,
Correct.
so you are conflicting two transportation sector, the ePlane
No,
company and the
you are Mr. Bigger. You are Mr. Bigger part, my friend. There are a lot of Hyperloop is one thing, Agnikul is one thing, ePlane is one thing,
Hyperloop.
X2 fuel is one thing, aerospace is one thing. So if you look at the way these things happen now, X2 fuels actually tries to make fuel from crude unsegregated municipal waste. So you get something, and there is something called aerospace, which can operate in any kind of fuel. So you take crude oil from here, you put this engine and operate. This can be used to operate bigger trucks, or this can be actually used to operate aircraft in the future. You have aircraft, and then these aircrafts can be carrying rockets also, which can be anything. So there is specific way of putting all these startups together. That's the whole idea of process.
And like Boeing, these companies, or
No. So I think you guys should step out of the main campus and come to this campus, because we have established a 60,000 square feet large facility where we are making our own aircrafts. We design our aircrafts, we manufacture our aircraft. Only at the production scale, we will be moving them to bigger partners like it can be anyone. It can be Tata, it can be Godrej, it can be Adani, anyone like that.
Okay.
But the prototyping will happen in-house, because see, it's like developing a baby. You have a baby, and you cannot put immediately to school. You have to teach mama, papa at the initial stage. That's what we do. We design that craft. We do it our way at the initial stage. Then we give it the bigger companies where they can design that craft in multiple numbers.
Yeah,
The
nice.
whole idea.
So I have one more question for
Yeah, go on.
benefit of students. What about the internship? Is there any thing for internship, or anybody
Yeah.
is
I mean, lot
interested?
of IIT Madras, lot of BTech students, IIT Madras students, non-IITians. In fact, there are people who have just completed their +1, and then they come and do internship at ePlane. We don't have any such bars here. When people come here, all we look is that do they have the attitude to learn. Other things come by default. You may be a born genius, but if you don't have the drive to learn something, no, there is no point in having that knowledge here. So knowledge without a purpose is useless. Knowledge with purpose is so powerful.
Yeah.
So, sir, how can we apply for an internship? Or
It's very complicated, man. You need to go to LinkedIn and send me your resume,
okay,
I mean, if at all you have, if at all your interest and your expertise or your work matches with any of the teams, and we do have enough money to pay you, we'll provide internship.
okay.
That's all. That's all. Cool. So if I may take leave, it's 8 o'clock. I have to reach my home at the 29th.
Over to you, Akhilesh. You say something
Yeah.
for the
Okay. So
students.
thank you for this insightful session, and it's a very great session to be honest. So everyone enjoyed, I guess. So yeah, thank you, sir.
Cool.
Thank you very much,
Thanks a
sir.
lot for joining, friends.
Yeah, thank you, sir.
Keep pushing for a better India. Thank you.
Thank you.